In this video, we're meant to find the cosine of an angle that isn't all too familiar. 5 pi over 12, which would look something like this, and should be about 75 degrees, is an angle that we don't commonly memorize the cosines and sines for, because it isn't like, pi over 4 or pi over 6 or pi over 3. It isn't any of those core angles that make up the unit circle in such specific ways. But nonetheless, we must find the cosine, and we must not use a calculator. So how could we possibly solve this? Or at least put it in terms without trigonometric functions? Well, I'm going to pull up the angle addition identity for cosine, and hopefully that will make things a little bit more clear. So we know that the cosine of some angle alpha plus some angle beta is going to be equal to the cosine of alpha times the cosine of beta minus the sine of alpha times the sine of beta. All right. Now, is there any way that we can break up 5 pi over 12 into two angles that are added together? Well, there is. Let's try to break this up. So we have cosine of 5 pi over 12, right? Well, we can separate this a little bit. Let's try to find things that we recognize. Well, there's cosine of, what if we took out something familiar like 2 pi over 12, which is pi over 6, 30 degrees. And what would that leave? That would leave 3 pi over 12. If we simplify these out, this is going to be the same as the cosine of pi over 6 plus, pi over 4. All right, so those are both angles that we know. And we actually should have memorized the cosines and sines for those angles because it's good to know those by heart, and it's easy to know those by heart. It's, of course, not easy to know the cosine and sine. In fact, it's impossible to know the cosine and sine of every single angle because, of course, you can break down the angles into infinitely small fractions, etc. So how are we going to solve this then? Right? So the cosine of pi over 6 plus pi over 4 should be equal to, all right, and I'm gonna write this down here. The cosine, I'm just gonna write this out, of pi over 6, how we have it written above, times the cosine of pi over 4 minus the sine of pi over 6 times the sine of pi over 4. So let's replace these values with what we know they are. So this is going to be, what's the cosine of pi over 6? It should be square root of 3 divided by 2 times cosine of pi over 4. That's 45 degrees, right? So 1 divided by the square root of 2. These should just be known. Minus sine of pi over 6, that's 1/2, times the sine of pi over 4, 45 degrees. That's still going to be 1 over the square root of 2. Or you can write 2, square root of 2 over 2, whatever. But I just do 1 over square root of 2. So let's simplify this at least a little bit. That's going to be square root of 3 divided by 2 square root of 2 minus 1 divided by 2 square root of 2. This simplifies out rather quickly to square root of 3 minus 1 divided by 2 square root of 2. And this is as far as I'm going to take it. Notice we now have the cosine of 5 pi over 12 in a form that does not involve trigonometric functions, and we did not use a calculator. Again, for the same reasons that this is useful in our more geometric example from the last video, often it's important, whether you're simplifying or actually trying to solve a problem, to break trigonometric functions like this down into slightly more algebraic parts like this, where we can approximate things like radicals, or even use a calculator if we have calculators that can do radicals, but for whatever reason don't have access to trig values. Of course, the former option is the most common, but in general, it's definitely important to know this as you move forward in math. We're going to be moving on to an example on the tangent identity for angle addition in the next video, and I hope you enjoyed this one. Thanks for watching.